Hey everybody, welcome back to Faraday Research. Sorry about this last weekend. I haven't been around. Here in Canada, it was our Thanksgiving weekend. So, in my free time that I did have on the weekend, I've been doing some research on Tesla coils. Because I'm doing a Don Smith generator, I figure I better educate myself on making Tesla coils the proper way. So, let's get right into it. Oh, by the way, if you haven't become a member of my subscribers, you can do so in the bottom right hand corner of the screen. And also, if you like the video at the end, give me a thumbs up. And also in the description, I have my link for my Patreon page. So if you haven't become a Patreon and support my work and my research and to get this new generator built, that would be greatly appreciated. You can sign up. It's very easy. Patreon's a very reputable company, and you can become a member there. So let's get right into it. Tesla coils. Well, basically, the Don Smith generator is basically a Tesla coil. So I'm going to stop using the word Don Smith generator because really it's not his, for one. So I'm going to call it the Tesla coil transformer generator, okay? Because that's really what its proper name is. So the Tesla coil is basically a transformer that doesn't have a metal core, all right? We can get into the reason why he doesn't use a metal core. That is something totally separate from his original concept. Now, as far as building Tesla coils, I've been doing a lot of research on the proper way and the improper way to build a Tesla coil. Okay, let's start with the secondary winding because probably this is the most important part of a Tesla coil. So, the material that we use for a tube, okay, as you can see, I used a paper tube. Okay, apparently from my research, that the paper tube is probably the worst thing you could probably use for a Tesla coil. Number one, it's not a dielectric. And number two, they have a tendency to retain moisture inside the paper. And that's what you don't want. If you get any moisture in there, it's going to affect the performance of your Tesla coil, which is very, very important. So for the project that I'm doing and for the potentials that I need, basically this is an amplifier. So you have the L1 coil that goes around, okay? And that has to be determined specifically because along the length of this Tesla coil, there's going to be a sweet spot where you get the resonant frequency. It could be here, it could be here, it could be here. You don't know until you actually test it. So the way you do is you test it with a light. So you would hook up a circuit to a secondary, you would hook up your resonant frequency at a certain point. You have to start somewhere. And then what you do is you get a light, hook it up to a coil, wrap it around. And then when that light's lit up, you know you can adjust and slide the primary coil in the position to where that light is going to become the brightest. And then you have found the sweet spot. That's the easiest way to do it. As soon as you determine where that sweet spot for your primary winding is, then you would fix that wire in that position. Now, the material, going back to the paper tube, your question is, okay, what is the best material for this? So it's got to be a dielectric. Now, some people use PVC, but one problem with PVC pipe. If you got black PVC, apparently there's carbon in it, and that's what you don't want. So if you're going to use a PVC type material, plastic, it is a dielectric, yes it is, but you don't want PVC that has carbon in it. So you have to find a material that, okay, if it's PVC, you got to find out the actual makeup of that PVC to make sure it doesn't have carbon in it. Carbon is something that you want to stay away from because it wrecks the field, it throws everything off, and it actually can short it out, believe it or not. So that's what you don't want. Now, the choice that most guys who are experienced in building Tesla coils are using acrylic, the see-through acrylic plastic. So that is the material that I'm going to try to acquire. I have a couple of stores nearby that might carry it. Now, also, as far as output's concerned, this thing's about 1 inch diameter. All right. I need to go to something that's about 3 inch diameter because you're creating a coil, so you're creating a field. So the bigger that coil is, the larger the field you can create. So I have to go to an acrylic plastic with at least a 2.5 to a 3 inch diameter. All right. Very, very important. Now, also, this coil here is way too small. So this one here is about, I would say, about 5 inches long. Okay, we're going to have to go to probably an 8 to a 10 inch coil. All right. So we're looking at, this one here is using 26 gauge magnetic wire, okay, with a coating on it. We're probably going to have to go to, I would say, up to 1,000 turns, maybe even more. So my new Tesla coil that I'm going to be making for this project is going to be 8 to 10 inches long. I don't know yet. I'll have to see what's available for me in my area. So it'll be 8 to 10 inches long. It's going to have 26 gauge magnetic wire. Some people even go thinner than that, but I find 26 is thin enough, but I can still actually work with it. Like if you're working with wire that's so bloody thin, it's hard to work with. When you're trying to clean off the ends, they break easy. It just becomes a lot more fragile, but it does increase the frequency and the power of it. So this one here is 26 gauge. I'm pretty happy with it. It's pretty durable. So I think we're going to go with the 26 gauge. So we'll go with an acrylic tube, 26 gauge wire, and it's going to be 8 to 10 inches long. And I'm going to try building 2 of them because there's 2 different ways I want to go through. A wireless power transfer or an actual direct transfer from the main coil itself. So that's more or less like the Don Smith style generator. He's actually extracting the power directly from the secondary winding of the Tesla coil. But we also can do the wireless too. It still leaves our doors wide open to do that. So that's going to be the plan. So, reading up on Tesla coils, educating myself on Tesla coils, now I know what I need to do. This thing for, running that small little DC motor, okay, yeah, I can do it just barely, but apparently this is really way too small for what I'm going to be doing. So I got to size it up. So if anybody has any questions, comments, or whatever, you can do it in the comments below. Definitely, I'd like to do some correspondence with people that have experience building Tesla coils. Tesla coils are kind of a new thing to me, but I understand the concept. I understand a lot of the physics that Tesla was working on with this. Definitely, there's huge potential with the Tesla coil. And the sad part is we don't use half of his stuff today other than AC current. It's because a lot of this stuff was really suppressed. And, especially when it comes to like wireless stuff and, ramping up the power in a transformer, because basically a Tesla coil is a transformer. He pretty much invented it, but it didn't have a steel core in it. So I'm starting to find out now, actually, getting an electric motor running using a coreless Tesla coil is totally possible. It's just my dimensions of what I was using is too small. So I got to ramp it up. I got to get it to about 2.5 to 3 inch diameter, acrylic tubing, 26 gauge wire, and at least 1,000 turns. So I think that's going to be my focus for the next couple of weeks, is to get a couple of really nice coils made. And I think in the process too, I'm going to make a new coil winder. I have a very good motor that I'm going to use for the coil winder. And it's going to be pretty heavy duty. Like it's one of those ones that you use for scooters. They're like, I think you could put 24 volts in these things. And they got quite a bit of torque, and they're very sturdy motors, and they got the motor mount already built to them. When I get that motor, maybe in the next video, I'll give you the link for that motor. and I'm actually going to build a new coil winding machine, which is going to be kick-ass. So, anyways, yeah. Anyway, I got to get back to work. It's Tuesday here. My holidays are over. I had 3 days off. It was good to get some rest a little bit and be with family. So it was a good weekend. I feel refreshed and I feel charged and ready to go and get this project done. I should be doing a video or a podcast again with Bernie on his site. So that'll probably happen sometime this weekend. We'll let you know when that's going to happen. And yeah, all right. Cheers, everybody. Give me a thumbs up. Don't forget, I got my Patreon. Sign up as soon as you can. And we'll see everybody soon.